Demis, thank you so much for coming along to our conference. And DeepMind's already been referenced several times. Actually, if you wouldn't mind, just tell us how did you start all of this, and then I'll come on to.
Sure. Well, look, it's amazing to be here. Thanks for inviting me, and some fantastic talks this morning. We started DeepMind nearly 15 years ago now. Which is sort of hard to believe. It was sort of before the AlexNet paper, and we saw some trends, both in computing trends, algorithms like deep learning and reinforcement learning, this new type of AI which, instead of being programmed with the solution, like the classic AI systems in the 80s and 90s, they learned for themselves. They were learning systems that learned directly from data, they learned directly from first principles, from experience, and actually able to do impressive things. And we sort of bet on that, and also some neuroscience ideas about how the brain worked, things like memory systems. And we brought that all together back in 2009, 2010. And we felt that if we put that together with some of the best minds and engineers in the field, we could make very quick progress. The field was poised to make this enormous, as we've seen, exponential progress. So we sort of thought of DeepMind as like an Apollo program effort for AI. And it turned out we bet on those, the correct kind of trends. But even then, it's still quite, surreal to see where we are today, even though that's what we predicted would happen if we were to make that kind of progress with this kind of AI system.
And it's a large operation today with a lot of people doing extraordinary bits of research and work, right?
Yes, it's huge now. It's several thousand people. I think it's probably one of the biggest research groups in the world in any field. And it combines cutting-edge research in many, many different areas, along with world-class engineering. And actually, modern AI is really big in sort of industrial operation, combining the best of both at scale, both hardware, software, and algorithmic ideas.
So, Demis, one of the things that, because I'm talking a lot, obviously, to policymakers, and I would say that whereas a few years ago they were kind of thinking, yeah, technology, yeah, that sounds interesting, right? Today they definitely think something's going on, but I still find when I say, this is really the big thing,
yeah,
they kind of, yeah, well, maybe. How big give us a sense of where you think this fits in the sort of history of innovation and economic advance and so on. Because frankly, it's better coming from someone, politicians become adept at talking about things they know nothing about, but it's, but you do know what you're talking about, so it's better coming from you.
Well, look, I've been working my whole career on AI for nearly 30 years now, and the reason was the sort of insight that I had back in the 90s was that if you look at modern society today, modern civilization around us, I often think about this when I take a transatlantic flight. It's incredible what the human mind, i.e. intelligence, has built modern civilization. And if you were to wind back 10,000 years, pre-agriculture, and tell a hunter-gatherer, that we were going to be flying on these massive, machines across the oceans, it would be unthinkable. And that was the power of intelligence that created that, human intelligence. So if we could replicate that and kind of make intelligence an abundant tool, if you like, it would be unbelievably transformative. There'd be almost nothing that you couldn't use that for if you built that in a general way. So to me, it's been obvious for many, many years that AI, if it was possible, and it seems that it is, this general kind of human level AI sometimes call artificial general intelligence, it would transform everything. So it will be at least as big as the Industrial Revolution, possibly bigger, more like the advent of electricity or even fire. I think it has the potential to be one of the biggest inventions humanity will ever make.
And when you come and think of it, you think of the practical applications of that. It stretches across everything.
It does. So I think building this in a general way, these systems, they're not sector specific, they're not domain specific. Whatever kind of data you put in, if there's structure in that data, these systems can potentially learn about them. And so I'm very excited about using AI for everyday productive tasks. So, amazing digital assistants, and reimagining the workflow. I think over the next 5-10 years, we're going to see incredible gains in productivity, both in the personal domain, but also in the work environment. But then the number one thing I'm most passionate about, and I've always wanted to build AI for, is to accelerate scientific discovery itself. And we've led the way in that, and probably the most famous example of that is our program AlphaFold, which solved the problem of 50-year kind of grand challenge of what's called protein folding, determining the structure, the 3D structure of a protein just from its amino acid sequence, its genetic sequence, which has huge implications in drug discovery and disease understanding. And I think that's just one example of what we're going to see in the next decade of many scientific breakthroughs in areas like energy, material science, mathematics, weather prediction, and climate, all sorts of areas, healthcare, that AI is going to be instrumental in.
I mean, I suppose anything that requires a lot of research, the effect of AI is just to accelerate all of that and take it to a higher level of intellectual capability, right?
Yes, exactly. So, you can think of it as, in the next sort of decade, as the ultimate tool to help human experts, whether they're medics or scientists, kind of take their skills and find new breakthroughs and find big insights into these enormous amounts of data that we're creating in most fields. I used to say when we started DeepMind that if you remember in the early 2000s, big data was a buzzword, right? And I used to say big data is actually the problem and AI is the answer. Because, before the advent of AI, there was all this data, both medical and industrial and so on. But the question was, how can you possibly by hand find all the insights buried, potentially very valuable insights buried in that enormous, exponentially growing amount of data? And actually, AI systems is the answer to that. And I think whatever domain you think of, and I wanted to ask you about maybe how we apply this to NHS, and I think the opportunity in front of us to apply AI to public services is exactly that, which is enormous amounts of data, experts kind of overwhelmed with that. But if we could triage it with AI, that would allow the experts, whether they're doctors or nurses, to focus on what they do best. I don't know whether you're thinking.
Yeah, no, absolutely. So, I mean, to take it down specifically, if we just take healthcare, I mean, it should transform drug discovery and development, right? So you'll be able to do it you'll be able to find better cures and treatments and at a much accelerated pace. And then secondly, and this is where I think is interesting when you look at something like the National Health Service, we should be able to take all the data that there is within the healthcare system and both use it in order to analyze what's happening in our healthcare system, so health policy, but secondly, to be able to create kind of digital assistants, right, where a doctor or a nurse is able to call on all the accumulated knowledge in our country and indeed elsewhere, right? And then thirdly, for the patient to have access to information, not just their own health information, but the potential for treatment, right?
Yeah, I agree. And I think there's sort of enormous new opportunities as well of things like personalized medicine, where you potentially design a drug or a treatment that's specifically tailored to an individual's metabolism, reduce side effects. And then the other big thing, I think, is preventative healthcare, where you actually predict beforehand before someone gets ill, or maybe they're about to get ill, and perhaps you intervene beforehand, which is a much better outcome for the patient, and also potentially economically as well. So it's a kind of win on all, win-win really. So I think there's huge opportunities there. And And I think government, maybe that's going back to sort of ChatGPT moment and other things. So those of us who've been in the industry for a couple of decades, we've been working at the coalface, improving these systems. And then I think one of the benefits of ChatGPT was it brought it to the public's attention. Because, of course, everyone uses language, and chatbots are very visceral in that sense that everyone can kind of get a feeling for what cutting-edge AI looks like, very hands-on. And I think the good part of that is that governments have sort of woken up to the potential of AI, and we saw that at the UK AI Summit, which I think was a huge success last year and is being built on. I think that's been very, very, very gratifying to see that governments educating themselves about what's coming. But I'm still not sure they fully understand the real, the unbelievable implications that are to come. We're only scratching the surface. I don't know how you feel.
I think for a lot of the leaders I talk to, ChatGPT is still a bit of a toy. Although I had an interesting experience. I was at some conference and there were various presidents of countries speaking before me, and one of them got up and gave a speech about green energy in his country. And I thought afterwards, it's a bit boring, that speech. So I put into ChatGPT, give me a speech from the leader of our country. I won't say which country X on clean energy. 10 seconds later, I had a really good speech, actually. And I thought, it could be less redundant as well. But one thing that's really interesting to me, digital assistants, right? Because sometimes people feel this is just quite a scary thing. I mean, it can replace the workforce, but you can think about it as a co-worker. I mean, if you're talking about a digital assistant, what sort of things would it be able to do?
And I agree with you, by the way. I think today's sort of chatbots are a little bit toy-like. I think there are very useful and valuable use cases, summarizing, long speeches and documents and things like that is very useful for. But it's still, but they're obviously impressive as those systems are. There's still a lot of flaws with those systems that we're trying to improve and correct. Things like hallucinations, but also give it new capabilities like planning and memory, which I think are really required for these assistants to be very useful in everyday life, so that all of us use it all the time. And I think we're moving towards that. So with our systems, Gemini, which is our versions of these large foundation models, we built Gemini to be multimodal from the beginning. So that means it doesn't just deal with language. It takes audio, video, image, coding, so all these different modalities. And that's critical because we as human beings, we exist in a very multimodal environment, right? It's not just language we use, although it's a critical component. It's the context that we're in. So I think for a system like this to be truly useful in your everyday life, it has to understand a little bit more about the context that you're in, and the spatial context, the visual context as well. So that's what we're moving towards with our new systems, which we call Project Astra at the moment. It's a kind of prototype where you could imagine through your phone or glass or some other device, it not only can you converse with it, it actually understands the situation that you're in, understands something about, has some memory, so it can sort of refer to previous conversations you've had and actually build up an understanding about your preferences and what you do and what you find useful and recommend things to you, things like that. So I feel like in the next maybe 2-3 years, we're going to start seeing, we call those things like universal assistants, that will kind of come around with you on different devices and help in, seamlessly in everyday life, both work and in your personal life. And I think it's going to be amazing.
Which will drive big changes in productivity, right? Yeah. So, I mean, Gemini today and the level of investment that you guys have had to make in this, billions and billions of dollars, right? Yeah. So this is also probably a level of investment that government really can't do. So but give me a sense of, so these large language models, the two questions I wanted to ask you. The first is, how much better are they going to get? How faster? And the second is, if you were a government today, why wouldn't you want to have all of your data on in a cloud-based infrastructure where you could analyze it, all of it, right? And which you could feed into one of these large language models and actually adapt that model for your own country.
Yeah. Well, look, I think in terms of how fast these models are still improving, so, all the big companies, the big labs, leading labs are spending billions and billions of dollars on the compute infrastructure and the and the talent required to build these models and come up with new algorithms, that's going to continue. There's an interesting debate at the moment in the field about how long will that improvement curve just continue with existing methods, like Matt mentioned transformers, a revolutionary architecture that allowed, I think it was invented in 2017, that has allowed to these new systems to scale to the size they are. But it's my opinion that I think that we're still going to need a few more big innovations before we get all the way to human level intelligence, to artificial general intelligence. Certainly on things like planning and memory and tool use. So things like, which we sort of calling in the field, agentic behavior. So building towards systems that are capable of achieving goals. So current systems are kind of passive. You kind of input a question, it gives you an answer. They're kind of question answering systems, very smart question answering systems. But the next stage is actually bringing in some of these technologies that we've developed for games, like AlphaGo, where you're actually able to give it an objective, like win a game, and come up with a new strategy, come up with new plans, perhaps even invent something new. So that will be a whole another leap ahead again of the types of technologies that we have.
So you could, for example, if you were a country looking at policy on, I don't know, how you make the most effective grid system for energy efficiency, you would be able to use that in order to give you a plan that would accumulate all the wisdom that there is in the world on this particular point.
Yeah, so that's exactly right. I think we're going to see in the next era, although these models, these foundation models, take a lot of resources to make. There's the whole open source technologies coming out, so versions of these that are freely usable for anyone. Also, I think we're going to start seeing services where governments or companies can take one of the best existing models and then fine-tune it further on their own data. So going back to what you're saying about government putting all their data in some secure data center or database, and then taking one of the leading models and then further training it on that data. So in a way, it makes kind of like uniquely fine-tunes that model to that specific purpose and that specific data set. So that could be government, it could be NHS, it could be other data sources.
Right, like and the big investment you're making is in the actual foundational model. Right, adapting it is not such an expensive business.
No, exactly. So adapting it is today is currently a fraction of what it costs to build it. It may be that more resources, and we're starting to see this, go into the post-training stage, this kind of fine-tuning. There's a lot of gains there, I think, to be made. So that's where a lot of the research is going on, is what should you do further after the models have been pre-trained? What can you do on top?
There are 1,000 things I want to ask you, because it's so interesting and important. But I just want to ask you about what the UK should be doing. Yeah. But just before I come to that, just to explain for people one more time, I think what people sometimes find difficult is the difference between artificial intelligence, generative artificial intelligence, and artificial general intelligence.
Yes, sure. So, generative AI is the type of AI that we're seeing at the moment that kind of creates language dialogue or things like images. So it's a particular type of AI. And then AI itself is the general term for the whole field. And artificial general intelligence, which actually one of my co-founders, Shane Legg, coined back in 2000, is this idea of getting to human level general intelligence. And that's important because then you have a truly general system. Because our minds are general, we can turn it to almost any task, right? The human mind, it's incredible, and so that's the kind of generality we're after in our artificial systems.
And with an IQ of what?
Well, initially it will be, that's an interesting scientific debate at the moment. Of course, at the moment we're far from human level intelligence across the board, but in certain areas like games playing, we're better than the best people in the world. Now the question is what will happen overall when we start generalizing this, but at the moment we're still not even at cat intelligence yet as a general system, so we got a long way to go. I think there's a lot of big breakthroughs that are still needed. I'm of the opinion that we're going to need both scaling the existing systems and some big new breakthroughs.
So Demis, in the time we've left, the UK, I mean, obviously partly thanks frankly to you and the efforts you made, but the UK's got a reasonable position in this field, but what should it be thinking about in terms of government, in terms of digital infrastructure, in terms of compute capacity and so on?
Well, I'm very passionate about the UK and the UK's position in this. I think we have many strengths here, national strengths here, our amazing universities producing incredible talent. It's one of the reasons we based ourselves here. We've got a long heritage in AI, through Alan Turing and even going further back in computing, Charles Babbage. So, there's no reason why the UK shouldn't be at the forefront of this. And then rolling forward today, I'm proud of the role that DeepMind partly played in creating the ecosystem that we see here, and people like Matt and Ian Hogarth and amazing people working in this ecosystem and building this out. So I think we've got to embrace that. We've got to embrace the opportunities. I think, very much agree with everything you said earlier today about, with the new government coming in. It's an amazing time right now, and AI could be a transformative for public services, the economy, but also our standing in the world. And I think actually the UK has a very important part to play on the global stage. And why I was encouraging, along with Matt and Ian and so on, the previous Prime Minister to take on board things like the summit. Because you've got the US, you've got China as the two superpowers, but I think AI is going to affect everyone in the world. It's going to affect every country, every nation, and I think it's important we have this international dialogue, international cooperation around both the opportunities and also some of the risks to do with AI. And I think the UK can be a kind of leading, in one of the leaders in the sort of the technology, but also a kind of middle way, if you like, along with perhaps other countries like EU countries, France, Canada, India, and so on. And I think if you look at the next tier after US and China in terms of who's at the forefront of the research, the most publications or citations, those kinds of measures, then the UK, Canada, France, they're in the next tier. So I think it's important that those countries get together and have a voice. And I think I'm very pleased to see, the US Safety Institute being set up, for example, and working closely with the UK one. And I think that immediately makes things international. You can imagine that expanding to G7 or G20, and then EU as well following the lead there. And I think that's going to be very important as we start debating how we want to deploy increasingly more powerful AI. But maybe, I was going to ask you, with the new government coming in, what are you advising Labour to do now in this technology?
I'm advising them to talk to you. No, I mean, I think what I'm trying to do is just, because it's having been sort of brought up in the political world, it is hard to get your head round just the sheer scale of the change, and it just requires a different way of thinking. And, frankly, a lot of it's difficult. Some of these, I spent all the last summer, much to my family's irritation, just trying to read about everything, like from Alexander Bell and the telephone through to the first transistor, through to, and also the terms are so confusing. Right, cloud. Why do they call it cloud? Right. I actually spoke to one head of government. He said, no, cloud won't work here. He said, we're sunny all year round. So it's but what I'm really trying to say to them is, I know you've got 15,000 things. I know what it's like in government. You've got all the geopolitics. It's, you've got morning till night. You've got meetings and schedules and all the rest of it. But just reserve a bit of space for thinking about this, because it is a revolution and it will change everything. And what you've just given us today is just so fantastic, and we are absolutely proud to have you at the conference. And thank you for all you've done, not just for DeepMind, but for our country in this field.
Thank you.
Thank you.
Thank you.